Okay, let's start with a word of prayer. Father, thank you for this opportunity to be alive and to be able to breathe. We are not too strong. We are not too smart. This is your mercy and your goodness that gives us that we can still breathe and we can still talk today. Whether that's a death of COVID or something else, we are alive and we give you thanks for that in Jesus' name. As we are going to study and revise and learn new things, we pray, Lord, you help us. Lord, we crown you King, that all we learn today will not forget, but give us understanding of everything. We honor you and we worship you. In Jesus' name we pray. Amen. All right, so someone just joined. So like I said, I was thinking about this and I figured out it could be a good idea for us to start with some two tools which are the most used, number one being Kubernetes and number two being Terraform nowadays. Well, no, the other way around, Terraform and then Kubernetes. And we're going to end talking about Ansible because Ansible is the number one configuration management tool. So I will try to draw something here and we can go from there. Let me try to reuse the red pen. Okay. So ultimately, let me try to go right at the bottom of this. The bottom, I think I have from, well, no space, no water. So ultimately, when they hire you as a DevOps engineer or anything, the idea is because they want you to help them take something from point A to point B. This is why they're hiring you at the end of the day. Now, point A is somebody's code that are written down, and point B is where the application that the code is going to create is going to be hosted. And when the application is hosted there, then why do you want to host the application here? It is so that you and I using our phones, let's imagine the application is what, WhatsApp. It's so at the end of the day, you and I using our phone can download WhatsApp and we can use WhatsApp. Now, I'm just using WhatsApp because it's an application that we all use. I could have said TikTok or whatever, just an example is WhatsApp. So they hire you as a DevOps engineer because they want you to facilitate taking code from point A to point B. Now, the series of steps that are going to be included in this chain of events vary from one company to another. But at the end of the day, that is why they hire you. Now, there are many tools that come into play while talking about going from point A to point B. Now, terminologies like CI/CD come up, CI/CD, continuous integration, continuous deployment. Why? Because machines, unlike human beings, do not make mistakes. Well, for now, machines unlike human beings don't make mistakes. So if they talk about human beings, they say, okay, for example, Mr. Lionel wants you to take this application and deploy it today. Now, I am a human being. It's possible for me to make a mistake and something crashes. And the company is making billions in the process. So they don't want that. They want to make it as seamless as possible so that there's no money loss. And so therefore, they want to make it automated. And that is why we come up with the idea of CI/CD. Why CI/CD? Because CI/CD means continuous integration, like we already know, and then continuous deployment, which means a process that can happen over an extended period of time without any human interaction. In such a way that even if Mr. Lionel is sick or he loses his job, is unavailable at the moment, the pipeline can continue without him being there. Now, we are still in the idea of taking an application from point A to point B. In this process, many tools can be used, and the tools vary from one company to another. Now, we're talking about CI and CD. The number one tool used by companies for this process is the tool called Jenkins. Now, like we know, the only tool, but it's the most used. Now, if you ask me, why do they use Jenkins the most? I would say it's because of Jenkins' capability to have an endless ability based on extensions or modules. Basically, Jenkins can do anything as long as you give him a module to do that thing. He can do almost anything. So if we take this Jenkins into consideration right now, I will put him into this line we're trying to create from point A to point B. We put Jenkins as the master key or the master servant one. Now this Jenkins is an application written in Java language. Now Jenkins has two ways of using it. You can use the Jenkins UI, that is the Jenkins console, which is on this page right here. We're going to do it very soon. This is the page of Jenkins here. You can see the logo right there hanging there waiting for us. That is Jenkins UI. And the alternative way of using it is a Jenkins, using a Jenkins file. Or you can Jenkins like Jenkins file. Now, if you can use Jenkins UI, that's really a good thing for the company because that means that at least you can do some work. But ultimately, if you are the only person in the company that can use Jenkins, then using the UI is not good for the company. Why? Because if tomorrow you lose your job or you fall sick, then the company is going to lose money because then nobody is going to be able to run the pipelines. On the other hand, if you can build the pipeline from point A to point B using a Jenkins file, then it's better for the company. Why? Because in case you are sick, if they have their Jenkins already stored in the GitHub repository, GitHub or GitLab or Bitbucket, anyone, even if you're unavailable, anybody in your company can just use your code and build the same pipeline with or without you being there. So today we're going to talk about using the Jenkins file to build our pipeline. Now, before we get into that, well, let's talk about the other tool. I've mentioned Jenkins. Now, the next tool we're going to talk about is a tool Terraform. Let me clear my screen a little bit. Let me clear everything. Okay, Terraform.
Oh.
Now, we have said Jenkins is the CI tool. What is Terraform? It is usually called an infrastructure as a code tool. What does that mean? It means he can help us. He can use a code to build an infrastructure on any platform. We can use him on AWS. We can use him on GCP. We can even use him on GitHub to build a GitHub repo. GitHub, Bitbucket, GitLab, Kubernetes. How do you call this other guy? Mesos. This is done by Mesos. I think this is done by Docker or something. So he can do almost every single thing. That is why Terraform right now is one of the most used tools in the world. Now, Terraform, of course, like we know, was created by HashiCorp. It uses a language called HCL, and he also uses JSON language, both of them. Now, that's a very basic of Terraform. I think we all know this. Let me go now to the next thing. Now, Terraform is a simple way of using it. Very simple, if you ask me.
Apologies.
Yes, sir, go ahead.
Is there anybody else hearing the echo, or is it just me? The static?
I hear the static a little, but I can still hear what Mr. Apple is saying.
Yeah, the echo is kind of distracting a bit.
Oh.
Oh, Candy, you were there?
Yeah. Hey, Aputi, long time.
Hi, everyone. Hi, Kenny. Okay, so maybe
we'll pause recording.
Okay.
Okay, maybe let's try this. Let's mute ourselves, everyone, then we'll see where the echo is coming from.
The echo is still there.
Okay, let's mute.
Is the echo still there?
Okay, just mute yourself. So let's see from there.
Oh, mute myself. Let me see.
and turn off recording.
Okay, let's try. Is the echo still there? I think it's better now.
Yes.
Okay, all right, let's go ahead.
I guess when we're not, for most of us, when we're not speaking, we should just mute ourselves. And then when we want to speak, we unmute to speak.
Good idea, that's perfect. All right, so we said Jenkins is a CI tool, but again, he's not the only, he's just one of the most used. Now, we were speaking about Terraform as being the infrastructure as code tool and the most used nowadays because we can use him to build our infrastructure automatically. It's a message. Sounds better. Okay, perfect. Thank you. So Terraform uses two languages, HashiCorp language and JSON language. Now, if you ask me, JSON is a little bit more complicated, so we're going to look at it from the HashiCorp language perspective of things. Now, why is Terraform so important? Because most companies nowadays, they want to be able to build an immutable infrastructure. I'll explain what this means, immutable infrastructure. Just like the English goes, it is an infrastructure that cannot be muted. Immutable, it cannot be muted, it cannot be changed. It is fixed and it is perfect. So by using Terraform, they can build, for example, think of it this way, they have an EC2 instance that they want to create, and they want to configure this EC2 instance to host MySQL, what else? To host Apache, to host, what else? Nginx, all about at the same time. You want to create one image of it and not ever worry about it anymore. What they can simply do is they write a HashiCorp language file with Terraform and keep it in their GitHub repository. Now, you will never leave their GitHub repository in such a way, if in the next 5, 10 years, they need this same EC2 instance, they can just go and pull it from GitHub and use it again. It is immutable. It's not changed from the past 10 years. It's the same exact image. All right. So let's go ahead and write some little bit of Terraform or HashiCorp language file. In this my repo here, you guys can later on fork it to use it for personal use. I actually made it kind of like a tutorial. This is what it's going to look like. We're going to have our AWS cloud here. You can see we have a VPC, the green box. Then we have our availability zone 1 and zone 2. Now, of course, it's connected to the internet gateway, which you can see here. We have 2 public subnets, 1 here and 1 here, and we have 4 private subnets. Now, by the way, what is the difference between the public and the private subnet? Just one thing. The public subnet is connected to the internet gateway, while the private subnet is not. There's the only difference. So the public subnet are going to contain 2 EC2 instances. Now I choose to make it this way. You can choose to make yours in the private subnets as well. It's up to you. And then we're going to have our RDS database, 1 in this private subnet in this availability zone, and the other as a standby for backup instances in case disaster recovery, basically in a different availability zone. And of course, we have our application load balancer in the middle, receiving internet connections to the internet gateway, hitting this load balancer is going to redirect it to the EC2 instance in this case, and this one here, in these 2 different availability zones. Now, let me go down here. At the end, you guys can, if you ask me, you can actually frog this repository and try to do the same thing we're going to do today. Now, all of this code here, I have them all at the top here. These are all the code here. So what I'll do is I'm going to click on code, make a copy of it, open my Visual Studio Code, and this is over here. And click on terminal, new terminal. Now, as I open the terminal right now, this is in PowerShell, but I prefer using Bash. So I'll click here, click on Git Bash. It's colorful, I prefer it, much better. So here I always like creating a new folder for any work I'm doing. You don't have to, but I like doing that. So I'll start with, I'll just create a folder, call it K8S, no, sorry, Terraform AWS project. Is sitting into it, Terraform project. Okay, then I'll clone my repository here. Let me try to make it maximize the size a little bit. That's much better. Git clone, I paste it there. All right, I do ls. This is a repository I've just downloaded here. Now cd into it. Okay, perfect. Now I want to open this repository in my Visual Studio Code. There are two ways I can do it. I can go on open folder and find my way to this place. So how do I do it? I'll click on open folder. Open folder. And I can see right now I'm in the ASUS folder. This is my home folder. After ASUS, I'm looking for what? I'm looking for T4M08WS. This is at the top here. Open it. Double click, and then I can click on select folder, and it will open a new window for me. And this is my code right on the left here. Again, like I said, it's all on the GitHub repository, which you guys are going to fork after this class, after this revision. Let me close this. Starting with the ALB. Now, we all know ALB means application load balancer. Application load balancer, which is what redirects traffic to the EC2 instances. Let me go back there. Let me push it to the left. Okay. So I'm going to start with this one right here. Let me actually put it side by side. So I put it on the left and put this one on the right. Better. Okay. So this is our application load balancer. Now, talking about Terraform, Terraform can handle 3 types of data. Terraform can handle strings. And when you talk of strings, anything in between of quotes. You can handle bools. When you talk of bools, you're talking of true or false. I can also handle lists. Lists basically anything in the middle of square brackets. And last but not the least, Terraform can handle maps. And maps is anything between curly brackets. Okay. So talking about that, you therefore understand that this is a map here. It opens and closes. That's a map. Another map here. That's a map. There's another map here and closes down here. Perfect. That's a map. What about a string? This is a simple string. You can see it's in between quotes. This is a string here. Another string. Another string. And let me look for another string again. That means, okay, this is a string up here, a string again here. Now we mentioned lists. You can look at the list. This is a list. It opens here and closes right here. Another list is here, opens, closes. Opens here, closes here. So I'm explaining this, I'm explaining all of this, so when you get this Terraform file into your computer, you're not surprised, you already understand what it's all about. Okay, let me clear my screen. We can continue. Now, Terraform works in blocks. Blocks. The first kind of block in Terraform is called the resource block, which tells Terraform what it is you want to create. Another kind of block which you will not see right now is the data block. The data block, of course, is the same way here. So it's data, okay, name of the data block, the second name, and they open the curly bracket, close curly bracket. And what does it do? Data block basically is what Terraform uses to download a code or some code from your AWS account which you want to use in your code. Say, for example, I have an S3 bucket in my AWS account. I don't want to recreate it. I want to just use it in my code. I can use data block to download it from my AWS and then use it in my code. All right. Another kind of block is called the variable block, which you use to create a variable. And like we know, variable is basically a placeholder. It can contain anything from a string to a list to a map, to a bool, which we just mentioned a second ago. All right. And the last one, let's do what we're talking about today is going to be the module block. Now, what's a Terraform module? Simple definition. Terraform module is a folder that contains reusable Terraform code, full stop. What does that mean? That simply means that if I take this, for example, all of this code here, I put them all in a folder, that is a Terraform module. All I need is I create another Terraform file out of that folder and I call it. That's all. But we're not doing that. We're not doing that today. Let's proceed. Oh, sorry about that. What am I doing here? No, made a mistake there. Let me open it again. Okay, perfect. So let's start looking at our code now. This is going to create a load balancer. You can see I called it external load balancer. Now, something to note. In your Terraform code, the name you give here is the name that you're giving Terraform. You're telling Terraform as the name of this resource. This name does not leave the Terraform universe. It doesn't go to AWS. It remains only in the world of Terraform. The name you give here. The name that goes to AWS is this one inside of the curly bracket. What does that mean? Everything in the curly bracket goes to AWS. Anything out of the curly bracket remains in Terraform. How that makes sense? So we have a load balancer here. We're calling it external load balancer, external ALB. We're giving it the name external LB. Internal false. What does that mean? It means you don't want this load balancer to be an internal, you want it to be an external load balancer. That is why they put this internal false here. What kind of load balancer do you want? You want an application load balancer. Like we know, we have three kinds of load balancer. We have the application load balancer, network load balancer, and gateway load balancer. But we are creating application load balancer right here. You have to determine the security groups. Now, in this case here, if you look at this, I've not given the name of the security group. I'm basically calling a security group I've created already. Now, where it is located right now? It's located inside of this one right here, web security group. SG is security group. So if we have to go through all of these files, the first file is application load balancer, database security group, EC2 instance, internet gateway, outputs file after the creation of the treaty application, provider information over here, RDS database information, routable, subnet, variables file, VPC information, and security group for the EC2 instances. Okay. So let's go back to this first file. So this first code is going to create our resource application load balancer, create a target group for the load balancer. Now, what is the target group? Like we know, the target group in AWS, it's what tells the load balancer the EC2 instances is supposed to redirect the traffic to. Let me try to draw something about that. We have a load balancer right here. And we have internet connection coming this way to hit the load balancer. How does the load balancer know where to redirect the traffic? Basically, based on AWS, this load balancer is connected to a target group. And this target group basically contains a list of EC2 instances, which we already have in our EC2 instance list here. EC2 instances, let me say 1, 2, 3, 4. These 4 instances are all named inside of this target group in here. So based on this target group, the load balancer is going to know how to redirect traffic to these EC2 instances. So that's what we have here, the target group. I hope that makes sense. Let's continue. So we have, after that, let me use this one. We have our target group attachment, which is the same thing. And then down here, we have the ALB listener. Basically, we're telling the load balancer what port to listen to. Of course, we want it to listen on port 80, which is the HTTP. That is very clear. That is for the ALB. Now, data.sh. This is basically, like you can see, a simple bash script, which is going to start up with our EC2 instance. So we're going to run our Terraform commands he's going to use this code and run these commands in the EC2 instances that he is going to create. So he's going to update the servers, install HTTPD, and then start it, and then echo the hello world in the index.html file. So we can check it in our browser at the end. Okay, database SG is the same thing, security group, but this time is the security group for our database that we're creating. Databases, this one here, 1, 2. And of course, you see we're allowing port 3306 because that is the port for databases for this particular database. All right, EC2 instance, like we already know, is going to create an instance. We're calling it demo instance. We're telling him to use this particular AMI. I'm not sure it is still correct. We're going to check if it's correct or not. Instance type G2 micro, key name. So in this case, you're supposed to already have a key file you created, ABC123. If I go to my AWS account, let me go to my AWS account over here, go to EC2, and I'll go and check if I already have a key pair created. So I'll go down here, go to key pair, and my key pair is called Saturday. All right, so I'm going to rename this to Saturday. Let me right click, change the occurrences, Saturday. Okay, perfect. Let me save it. Okay, that's done. We're going to continue. VPC security group IDs. Now here, I'm going to ask him to use the security groups I've already created in a different Terraform file. How do I do that? Please notice something. Notice something. It first of all starts with the name of the resource, the name I gave to it, and then the resource type I want him to use. First of all, the AWS resource name, the name I gave to it, and then the tag I gave to it. Okay, let's start it again. AWS security group. I wanted to look for it. Okay, in this particular file, you see there is nothing here like there's no security group in this file. We are in the EC2 TF. So let's go to the security group.tf one. I'll click here. This is a security group here. I'll click on him. So we can compare the same time. Let me actually maximize it so you can see it better. Okay. Let me put this on the open on the right hand corner so you can see. Perfect. All right. So here I'm telling him to use the AWS security group called demo SG. This is the AWS security group called demo SG. And I'm telling him to use the ID of it. So he's going to create this resource. This resource is going to have an ID, and that ID is going to be used by this code. I hope that makes sense. Remember, the good thing about Terraform is what is that Terraform is very intelligent. When I'm going to do the Terraform commands, he's going to scan through all of our files and then connect the dots I want him to connect. For example, in this scenario here, this is a very simple case of what is called implicit dependency. Because by seeing this, Terraform is going to understand that for him to create this resource, he needs to first create this resource. And then he's going to use this resource in this resource over here. He's very smart. I hope that makes sense when I say implicit dependency. It's just simple English. I hope that makes sense. It means that this particular resource is implicitly dependent on this other resource right here. We're all on mute. I hope that makes sense, everybody. I'm going to continue. So same thing here. Is going to create another instance and call this instance demo instance one. Use the AMI, this one, type T2 micro, use this VPC security group, put it in the subnet ID, which I'm going to create here. Same thing, he's going to use the subnet ID, which I'm going to create in the subnet.tf file, which you can see right here.
Forgive me for interrupting.
Yes, sir, go ahead.
I'm not sure if anybody has had the same question. When you say implicit dependency, are you saying that you still have to have the web you have to have that security group TF file and the EC2.tf file. And when you have both of those implicitly, Terraform is smart enough to know to do this step first.
Yes.
Before it does the other one.
Exactly. So basically yes, sorry, go ahead.
But if you're missing that file, then it's not going to work. It's not going to do the other thing because it's going to be missing the reference variable.
Yes, you got it. So the thing, wait, what's happening with this guy here? Just give me a second. This guy is I don't know what's messing up this guy here. No, something's happening with my Terraform file here. Let me open it again here. Okay, which on the right, Yes, so when I say implicit dependency, what I simply mean is when Terraform sees this code like this, for example, he knows that this means I expect him to look among every other file, every other TF file, and look for any code containing this resource block named demo.hg and with the type ID. So it's going to scan through all the other files in the same folder, look for it, and then make sure that file is created first before it comes and tries to create this one. I hope that makes sense.
Yes.
Okay. So that's what I meant by implicit dependency, in case you have that question about it. So we have that for this particular case now. Now, if you look at here, there is this file, you use that data, file data.sh. So this is what I was talking about, the bash script that's going to be run once we run it. Once we do the Terraform commands, this is the data.sh. So it's going to run those commands in this EC2 instance and also this EC2 instance. Okay, let me close these two files and we can continue. Internet gateway.tf is going to create an internet gateway, like we know, which is going to give access, the VPC access to the internet. Output.tf, create an output for us on our terminal. Provider.tf here, I'm supposed to give information about the region, access key, secret key. I'm going to do that after. RDS.tf is going to create a database, two databases. Routable public is going to create our public route table. Now, I hope that we understand the public route table is what allows for internet to access the subnet. That's why if I go to subnet.tf here, which I'm going to open in the right, let me make sure that both open at the same time. Let me open this one to the right. Okay. This subnet.tf, you can see here, for the subnet to be created, is going to need, first of all, the AWS VPC and then the CIDR. And they both are going to need access to the internet. And they only do that using the routable public that we've created. This one. I hope that makes sense. Now, vars.tf is just variables, like we said. You can see this particular variable is going to contain a bunch of strings. This is the VPC CIDR, subnet CIDR for subnet 1, subnet 2, 3, 4, and 5. We have 5 subnets, remember. VPC.tf to create our VPC. And web security group, the security group for our EC2 instances. You can see our EC2 instance is going to have port 80 open, port 443 open, port 22 open, and it's going to have possibility to access any website. It's going to have open access to any egress, and ingress is just port 80, 443, and 22. Okay, this is a very simple rundown of our Terraform 3-tier architecture I had to do first of all. So I'll go ahead and I'll close everything. I can leave just one open my terminal. Before doing that, let me make sure I go to my vpc.tf, sorry, provider.tf, and give the access and secret key. First of all, I'm going to use US East 1. Access key, let me go to my AWS account over here. Go to IAM role. Actually, I think I already have the access key in my computer here. Just give me a moment here. Okay, yeah, I'll use this one. But no, let me create a different access key to save time. Yeah, much better. Create user, create a different user. And let me call him any name, Terraform. Select access key, permissions. I'm going to simply give him the administrator access, review, create user. Now copy the access key into my Terraform code here. Access key. And the secret key. Copy. And then paste. Okay, that being done, I can proceed now. Open my Git bash. And like we all know, we have a bunch of Terraform commands, but the main ones we're going to use is a Terraform init, which is to initialize the Terraform machine. Terraform plan, which is where you ask Terraform to go and check your provider using these credentials and see what you already have in your terminal, in your console, and then compare with your code and see what needs to be created. That's what Terraform plan does. Then Terraform apply simply means is for Terraform to apply the plan that has created. So I'll go ahead and do that. Terraform init first. It's going to initialize. So when you do Terraform init, it does three main things. First of all, it's going to download the dependencies, these ones. If I had any module, it was also going to download the module's dependencies, but in this case, I have a module. So you will not download anything in that case. And also download our provider information. So we downloaded HashiCorp, AWS information, created the log file to log our information, and then initialize the machine. Okay, I hope that makes sense, everybody. So I'll go ahead and do my Terraform plan. When I do Terraform plan, he's supposed to go and check my Terraform, my AWS account using these credentials, compare the information on my account with what I have locally in my code, and see what needs to be created or destroyed. And based on what I've done right now, he sees that there's nothing, there are 22 things to add, 0 things to change, and 0 things to destroy. Now, there's a command I like doing a lot, which is the Terraform validate command. Terraform validate is the command you run for him to check your code, look if it is well written, any errors. He's telling us here that the configuration here is valid. But you can see something here, argument deprecated. So between the last time I wrote this code and today, Terraform has updated their code such that they're putting away this AWS_DB instance. Now they're calling it just DB_name, but I'll leave it for now. It's not too important. So the next thing I'm going to do now is the Terraform apply. Terraform apply. So right now, Terraform is going to compare the plan he has written and what is presently on my account, and then see what it needs to create. If I say yes, it's going to try to go and create the 3-tier architecture we have just looked at. Now, if we can unmute ourselves, do we have any question? I know this was very fast, but I tried to. Oh, okay, perfect. I like that error. No questions. Okay, let's go ahead. So this error you can see here is very obvious error. If we look at it together, it says error creating EC2 subnet. Invalid parameter value, US West 2B. Now, why are we having this error? That's because I changed the region to be US East 1A. So I'm sending him to work on 2 different regions, which does not work. So I have to tell him to actually do everything in a particular region. So I'll go to my subnet.tf and change this to be US East 1A, US East, let me rename all of it. East 1A here. And yes, we are good to go. I've changed everywhere. Now we are good to go. I finished changing. I'll save it. All right, and I'll go ahead and run again the Terraform apply. Now, if you don't want for Terraform to ask you yes again, you can just do Terraform apply, auto approve. He will not ask you yes or no. He will just go ahead and try to apply without stopping. You need to refresh where you ended and try to create from there. Questions? Are we okay? Does it make sense?
No questions from anybody?
I hope I didn't fast though.
Kennedy? Everybody just
it makes sense, but I'll still need to look more into it.
Yeah, if you see anything that you kind of stumble on, like when you ask like questions, just kind of ask. One thing you mentioned there, I could ask is when you write, so this is Visual Studio Code. When you wanted to do that global change on the US East, how did you just right click and, you know,
yes,
like that?
Perfect. So to do that, let me use a simple example. Let me go to this read.tf here. So if I want to do a global change, let's say there's a word here, for example, open source. And I want to change this word open source. I want every time the word open source is mentioned, I want to change it. Let me look for a word that's mentioned many times. Let me see files. Declarative. I don't know. But let me see, for example, cloud. Every time cloud is mentioned, how do I do that? I can right click, go to change all occurrences. And whatever I type here is going to be changed on every occurrence of cloud. Let me say I type here another, or let me say another cloud. Once I do that, everywhere cloud was mentioned is going to be changed to another cloud. So basically just cover the text. Okay, I'll change Terraform. You can see that it appears many times. Let me cover Terraform. Right click, change all occurrences. Let me type Terraform 1 and everything else. You see it's changing everywhere else. I hope that makes sense. That's okay.
Makes sense.
Okay. So you can see right now it's still creating our databases. That will take some time, obviously. But in the meantime, we can go to our AWS account, go to my EC2 instance over here, and he probably has already created our instances. You can see it's already running right now. Let me close this one here. Refresh. Okay, he's still creating. Let's go back to our code. Still creating. Still creating. Okay, if there are no questions, but Mr. Greg, I think you mentioned something wasn't clear. What was that you had a question on?
Oh, Greg?
Yeah, don't mind me.
No.
Just continue. I'm looking at it.
No, he's saying if there's any one thing, like just a small thing you're thinking that it's not quite clear, just kind of ask the question now. And while we're still going through the creation, you can just try to answer that question.
Yeah.
Well, one thing I was thinking is, it's like these, it's like, I guess when I'm in a company, I don't have to make these files myself. I just use, it's like I can go to GitHub and get these Terraform related files.
Mm-hmm.
Put it, guys, get it, create a folder, put those files in it, and initialize that folder with Terraform in it.
Yes, you can actually do that. It's true that I will. Let me see. Do we need? Let me see. Maybe what we can do is we can just try to write a little bit of code Because it's true, you don't have to reinvent the wheel. You don't have to. But if you ask me, I would say it's good to at least understand how it is done. Okay, let's try to do something. Let's try to do something. Let me create a new file, new text file, and I'll call it a Terraform language file. Okay. So while it's still creating, let's go to our browser. Oh, what's happening here? Shift this thing on the left. Oh, it's not shifting. What's happening here? Let me expand it. Okay, shift it. Okay, I'll go to Google. I'll show you how simple it is. I'll type here Terraform VPC, for example. VPC. And I'll go to the very first one. Basically, always go to the one with the website being terraform.io, always.
Yes.
Go there. And whenever I open that page, there's always an example. They always have a basic usage, always. For example, here they have basic usage. They have basic usage with tags. They have VPC with CIDR from AWS IPAM. Let's just go with this basic usage with tags, for example. I copy it, I come to my code, and I paste it here. That's a very simple example. Now, in the company, they say, please, Mr. Gregory, we have an IP address, we have a CIDR block to give it to you, you put it in here. Now, whatever they ask you, you can add here. Let's go back to the page a little bit. At the bottom of the page, you can see a list of arguments that your colleague or your manager may ask for you to add. You may need to have to add the CIDR block, the instance tenancy, the IPv6 CIDR block, the enabled DNS support. So based on what the ticket, the Jira ticket asks you for the VPC to have, you basically be using them, copying them from here. Now, in case you see most companies nowadays, actually, when you're going to join them, they're probably going to already have Terraform module created. They just need to use the module to recreate anything. They rarely ask for you to write the code from scratch. Rarely. It could happen, but it is rare. In case they say to use a module, let's look at how to use a module, why it is still creating. So let me go back to my Google, and I'll type here Terraform. Let me say Terraform module. Let's say EC2 instance, EC2, for example. And I always go to the website of Terraform, of course. Let me click there. And if I scroll down, they give you the link to the module over here, the source code if you want. And down here, they show you how to use the module. Actually, we're going to use this module right now. Let's do that. Let's use this module. Let's do that. So I'll go ahead and I'll click on this, open a new tab, download it. So copy this, and let me maximize this window. Let me create a new terminal while we're still working on the other one. And then this terminal, I'm going to do git clone, and I download that one here. That's it. Now, if I do ls, this is here, let me cd into it, cd into Terraform. Oh, I think, yeah, there, ls. So this is, did I cd into it? No, I did not do that. Cd into Terraform, AWS instance, it's 2 instance. Okay, that's it. So this one, I just downloaded it right now from the website. I'm not going to do any change on it. No change at all. Nothing. Okay. So cd, I'll come out of it. All right. And what I'll do is I'll create a file. I'll create a file. I'll call it module.tf. So touch module.tf. You can see the file has appeared on this side here. Module.tf, here it is. So what I'll do is I'll not write anything here. I'll just copy and paste. So you see how easy it is. I'll go back here, go to the Terraform website, and I'll use the single instance example they have here. I'll copy it, go back to my code, and I paste it in the file I created, module.tf. That is it. Now, again, what did I say? I said the Terraform module is simply a folder that contains Terraform code. And that is what we downloaded right now. The Terraform, this one, the Terraform that we just downloaded right now. This one. That folder contains Terraform code. That is a Terraform module. So to use it, all I need to do is I create a module block, call it module, give it any name. I choose, they give it the name here, EC2 instance. I can call it Tuesday evening, it doesn't matter. It's just a name. Okay, now the thing that matters here is the source. What is the source of this module? Now, by default, this source is the Terraform website. I can leave it as it is, or I can choose to use the one in my computer. Let's use the one in my computer. To do that, let me remove this, and I'll tell him that the source is, I can tell him /Terraform AWS EC2 instance. Where am I getting this from? This simply means that the source of this module is found in this same folder in a subfolder called Terraform AWS Terraform AWS EC2 instance. And this is that folder right here. I hope that makes sense.
Yeah.
Dot means here, and I put the name of the folder. Okay. Version of the module is 3.0. I didn't change that. I just downloaded like so. I copied and I pasted. Name of the instance, single instance, doesn't matter. AMI. Let's go and take a correct AMI. Let me go to my AWS account over here. Let me do as though I'm going to launch an instance, launch instances. Copy the AMI code down here. Let me take an AMI code. Let me take this one. Copy and paste. And paste it here. T2 micro username, key name. I'm going to use the one I created already called Saturday. Monitoring true. You can leave it to be false. Let me put false so they will not charge me for nothing here. False. VPC security group. Now I need to go and look for a security group that does exist right now on my account. So how do I do that? Let me scroll down here. Security groups. Let me look for one that does exist. I can see that there is this one here. I can copy this. Let me look for a simple one. Let me use this one here, for example. Copy it. Copy that name. And come and paste the name in here. Subnet ID. I need to look for a subnet that does exist right now. So what I'll do is, let me maximize this page here. Let me maximize it, sorry. Maximize it. This security group, I'm going to click on it. Click on this security group. So I can check what subnet it is linked to. What subnet is it linked to? Let me do it again so we can see it again. Let me go back. I selected this security group. This is it here. You can see the VPC it is connected to. I want to check what subnet is this security group connected to, because remember, the security group is connected to an instance, and that instance is connected to a subnet, or is under a subnet if you want. So you cannot choose a security group that is a different subnet. It must be in the same subnet with the EC2 instance of that security group. So I've selected this one. Let me scroll up here. I can see this under VPC ID 09452. I'll click on this security group. I'll click on it. And I can see down here the inbound rules, the outbound rules. I'm trying to look what subnet is this linked to. To do that, I need to go to the VPC page. I'll click on these services here. Services, go to VPC. In the VPC page, I can see the subnet on the left here. Click on subnets. And I can see there are many subnets right here. I'm looking for the VPC that is connected to my security group. Let me go down here. So we go back to my EC2 instance again to go and look at the name of the security group. Then go back here. Scroll down to security group. And I'm looking for the security group WebSG. Okay, now it is connected to the VPC called VPC 09452. Now let me come to this subnet page here. Which of these subnets is connected to the VPC 09452? I can see these two subnets are connected to this VPC. So it means I can use any of these subnet and it will work with my security group. Let me go ahead and use this subnet. Copy this subnet ID, copy it, go back to my code and paste it in here. Let me do it again. I made a mistake there. All right, let me cover it completely. Paste it there. Perfect. All right. So I just copied the module page. I just copied it from here. Remember, I copied it here and I pasted it in here. The only thing I've done is I've put my information here, 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 and here. That is it. That is how easy it is to use Terraform modules. Extremely easy. Okay, the next I need to do, of course, is I need to give this module my credentials. Okay. So before I do that, let's just go ahead and do a Terraform init. You can see how it starts. I'll do my Terraform init here. Oh, I made a mistake here. I made a mistake. Okay, before we work on this one, let's go and finish with the previous project because they're going to interclash one with the other. They're going to clash. So let's go back to our previous project. This one here. This terminal up here. You can see I actually made a mistake. The image ID had an error. Okay. The image ID was wrong. It says the image ID AMI does not exist. How do I correct that? Very simple. I'll go back to my AWS account. Let me go back to my AWS account over here. Do as do, I'm going to create an instance. So click on instances, launch instances. Then I can come down here and just copy it. I don't know how did I copy it wrong? Don't know. Let me copy it again. Copy. Go back to my code here. Open the ec2.tf and then paste it here. Paste. Paste. Okay, that is done. I'll save and I'll do again the command Terraform apply auto approve. Now, module installed. Oh, he's trying to look at this, my module.tf file. Let me delete this file for now. Let me rename it. Let me rename it to module, just module. So Terraform will not see it. No. No, I don't want Terraform to see this file right now. Okay, good. Let him not see it. All right. Let me run the command again. Apply auto approve. So the error we had here was because, remember, Terraform, when you run the Terraform command, he scans through all the files. So when it scans through all the files, he realized that there was something I added and it was this module.tf file. So I had to remove the .tf because remember, Terraform can only read files that end with .tf. Let me actually mention that here. Terraform can only read files that end with .tf, .tf vars, and .auto.tf vars. If your files don't end with these extensions, Terraform can never see them. These are the only 3 file types you can understand. And of course, you understand, you can also realize a file ending with .tf state and also .tf state.backup. If your files don't end with these extensions, Terraform can never see them. He doesn't even understand them. All right, let me clear it up. Let me clear that up. Okay. So let's go down. He should have finished by now. Okay, you can see he has finished creating everything. Apply complete. And this is the output we asked him for. Let me open here. So what do we need the output for? Sometimes your boss can ask you, for example, that he wants you to create an architecture and he wants from that architecture to extract some information to use for something else, for example, to create another architecture. In this case, I told him to extract the load balancer DNS name, and this is it here. So if I copy this right now to my browser, we should be able to see the website in our EC2 instances. So let me copy this. Let me copy it, go to my browser and paste it there. We should be able to view the content. You can see it over here. Can you guys see that? So this is right now being shown from our EC2 instances. Remember the architecture we had. Inside here or inside here. So we have the load balancer in the middle. So every time I refresh, it's going to be switching from one load balancer to the other. You can see it's changing. This number is changing. It's changing from one load balancer to the other because we have from one EC2 instance to the other, sorry, because we have two EC2 instances and have two different DNS names. Is that okay?
Yes. So basically, when you refresh the page, it's each time you refresh, it's almost like a new person accessing the web page. So the load balancer is going to the next available.
Exactly.
Load by EC2. The load balancer is switching.
Exactly. So let's imagine there are two EC2 instances here. This is instance 1 and instance 2. When I pasted the website in the browser, internet connection went and hit the load balancer. And like you know, the most used load balancer method is the round robin method. And round robin method says the first time someone hits it, he sends you here. Second time you hit it, he will send you here. Third time, send you again here. Fourth time, send you again here. If I had more EC2 instances, it was going to go from 1 to 2 to 3 in that order. That's the round robin methodology of load balancing. That's why every time I refresh, he will keep on changing and changing and changing and changing forever. Are we okay?
I am. I'm not sure about anybody else.
Mr. Greg?
Following. Understand the round robin method.
Okay. Did you have any question? Are we okay? Are we good?
Well, so far, I'm just looking at it to understand some parts, but I have to go over the video again later,
Okay.
you know, to get deeper understanding. But
Okay.
understand certain
Somehow.
parts.
Okay, that's fine. That's all right. So before we go, I want us to do the module part. So let me destroy this architecture. Terraform, destroy. Terraform, destroy. Auto approve. I want it to destroy everything. And then we're going to recreate the EC2 instance, but this time just with the module. Delete everything. Yeah. Everything. So even talking about Terraform again, one thing let me not forget to mention is Terraform. If you look at my code here, Terraform only looks at files at the first level. What does that mean? If, for example, you have your folder here, and in this folder you have Terraform files, and also you have a subfolder inside of here which contains some extra Terraform files. Terraform, when you run Terraform, apply Terraform commands here, he only see these ones. He cannot see this one because Terraform only works on the first level, and this is the first level to him. First level. This one here is a second level. Terraform cannot see. He only sees this one here. I hope that makes sense.
It sort of makes sense. When you say the levels, are you talking about like when you CD to the directories?
Exactly. Yes. Okay, let me actually use this shell down here. So right now, if I do, let me clear my screen. Right now, if I do ls, I am in a folder called Terraform Treaty Architecture AWS. And I have a subfolder right now called Terraform AWS EC2 instance. Now, when I run Terraform commands right here, Terraform any command, he can only view the files in this place. He cannot see the content of this subfolder because he only works on the first level, which is what he is seeing here. He cannot see anything in the subfolders like the ones inside here. Is it making sense now?
That makes a lot of sense.
Yeah, it only works in the it doesn't go to, it's like this Terraform AWS EC2 instance is like how am I going, is it like a directory?
Yeah, it's a directory. Yeah.
So it won't go into those, only the immediate files.
Yes, exactly. So when I run my Terraform commands here, he will see everything here. But anything like this, he will not see it because it's a directory that contains something. He doesn't care. The only way for him to go and check out the content of any directory is if I explicitly tell him to, like I will do in this my module.tf. Here, I will tell him to explicitly go and check it. That's the only case where you can check. If you don't tell him to do, he will never do that. Okay, he's still destroying. So while he's destroying, I'm going to delete everything here except the module.tf. So rm-rf alb.tf database data.sh and the ec2.tf. I'm deleting everything so we can have just our module. So we can work on the module rgs.tf. Readme route table subnet or subnet terraform.tf state terraform.tf state .backup vars.tf vpc.tf and websg.tf. See all of that. That's okay. Still destroying. Sure, that's fine. Okay. So now if I do ls, I have just the module file. So let me rename him again. Let me rename him to module.tf. Now Terraform is going to understand this file as a file. Good. I've deleted everything else. Let me delete everything else up here. Don't save. Delete. Close. He's still destroying. He'll take some time to destroy all of those things. Let's continue. So now I'll do again the Terraform command. Terraform init. It says cannot apply version constraint to module because, okay, that makes sense. Yeah, that's true. Yeah, I forgot about that. Okay. So basically what's happening here is I just tried to run the Terraform init command. And like I told you, Terraform init does what? He first of all downloads the module files based on your code. And looking at this, he's seeing that I'm telling him to use a local code based on this path I've given him here, locally. And local codes usually don't have versions. So what he's saying here is cannot apply a version constraint to this module because it has a local path. So what I'll do is let me remove this one first of all. Now tell him, let me see if it has finished up here. He's still destroying. Okay. I'll tell him to init again. The state file cannot be read. The process cannot be accessed. Something is using it. Another process has locked it. Okay, so we have to wait for this guy to finish. Oh, shoot. Okay, no issue. Are we okay so far? What I'm trying to do? Are we clear?
Somewhat.
Yes.
Somewhat. Okay.
I have another question.
Yes, sir.
Well, just call me Greg. The stuff, the files, when one copy those files from the Git repository,
Yeah.
I guess those were more complex files. When I think of Terraform, normally I figure that there'll be a main.tf, a file.tf, and then one other third file. But in this case, there were a lot of files over there.
Yes, sir. I like that question you asked right now. I like it. Really like it. So the one thing about Terraform is Terraform works with anything.tf, any file name.tf. Now, most companies have this way of doing things. Company methodology is they have a main.tf that contains resources to be created. They have a variables.tf that contains the variables, the vars to be created. And they have usually something else, like for example, that main.tf, that variables.tf, and they could have like database.tf or something else. But the main file they usually have is main.tf that contains the resources to be created, and the variables.tf that contains the variables to be created. Now, what I've done today is the way I did the repository, the code was, I basically created TF files and named them based on what they are going to go and create, which is fine. But in company setting, that would not be fine, because company basically, they want to have one file, the main file that contains everything to be created, variables.tf that contain all the variables, and also they could have something like something.tf vars, that.tf vars that contain the values of the variables. Usually these are three main files of the company: main.tf, variables.tf, and anything.tf vars. These three files are the same. So basically, Terraform doesn't really care about the naming convention. He cares about the extension .tf vars, and the other extensions. If you want, you can call it Saturday evening.tf. As long as you can see his code inside of it, is fine. But in company setting, it is usually main.tf, variable.tf, and any other file.tf vars or something like that. Thank you for that question, Mr. Greg. Does that make sense?
Yeah. Another question is, like, I know that at some point, perhaps some certain, access keys and credentials need to be stored in a secret, in some sort of file.
Yeah.
I guess that file is in
like a vault.
So it depends on companies. All right, so talking about that, that's a fantastic question as well. Let me clear this one so we can talk about that. So talking about credentials, Terraform has a bunch of ways of handling credentials. You can handle them if you put them in any file called .tf vars, which companies will not do because it is very private information, or they can lock it inside of the environment variables of the server you are running it in. So what we do at our company is, since we run Terraform from EC2 instances, in our case, we have stored Terraform, we have stored our AWS credentials in environment variables in the EC2 instance, So when I run my commands, my Terraform commands based on the ticket, I never actually see the credentials. Terraform basically uses the credentials in that EC2 instance to create anything on our architecture, on our infrastructure. So there are many ways Terraform can handle credentials in the TF vars, in the environment variables, You can also handle them in, you can call them directly. So you can have a file. You can have a file. Let me see, you call a file. You have a file. And you can do your Terraform, for example, apply --var file is equals to anything.tfvars, for example. And let me say file.tfvars. This is another way you can do for Terraform to use credentials without actually storing the credentials, because companies don't like to just store it. It's not even good practice to store credentials. So they usually store it either as environment variables or in a file that you can call on the go, or in a tfvars file. There's also another way they can do it, which is not the most used. They use the Terraform Vault. Now, some companies use it, others don't. Terraform Vault is like a vault, like a place where they keep credentials, and then Terraform, while running, can call them. And of course, the last option for some companies, they basically work with Terraform Cloud. Terraform Cloud basically has a way to store credentials in it that the company, that others in the company like myself cannot access it, but the bosses can access it and they can modify it. And Terraform can just use the credentials in the cloud and then run the commands on the AWS or GCP or whatever else. Does that make sense, Greg?
Yeah, it makes sense. So for instance, let's say you are doing a module and that module at some point needs to use draw credentials from some file. So the file is in the EC2 instance. So in order to use those like, for instance, let's say you need the secret key to do something, So let's say you need the secret key to do something. So you put the command that, is supposed to do something, then you put, like, for instance, secret key equals the name of the variable, that secret key is equated to.
Yeah.
So that is to prevent hard locking.
Yeah, hard coding the variable, the information. So in that case, let's take that scenario. Now, if you want to store credentials, let's say for secret key, the way Terraform will see it is you can create a variable, say, let me say on Linux or any Linux server. If I do tf_var _ secret key, this clearly tells Terraform that this is the variable for the secret key. When I started with tf_var_, he already understands that this is going to be the variable for the secret key. So when I run the Terraform apply command, I can just run Terraform apply like that. He'll go and look for the variables in the environment variables and use it. Now, in your case scenario, in most companies, they probably will not give you the secret key. They would have saved it already in the EC2 instance before telling you to go and run the commands on that instance. Or in other scenarios, they already have a pipeline, and then Jenkins is going to trigger that pipeline to go and run the Terraform commands based on the company scenario. I don't know. But if in your company, you have direct access to Terraform, like I do, when I run the Terraform commands, it basically picks up the credentials in that instance. Now, let's take a scenario here. Let's say, for example, like in our company, you have many environments. You have Ing environment, you have prod environment, you have QA environment. And for each of these environments, you have different variables you need to use for a particular thing you're creating, for example. Now, the credentials they'll give you for Eng, prod, and QA, like in my case, it is put in a file called eng.tfvars. So to pick up the variables in this file, this variable in this case, they are not company access key or secret key, because if they give me access to that, they don't know if, for example, I can access the account and then run an instance in China and they don't know about it. So they don't give me access to it. So the variables in this file are inconsequential. I cannot use them, but I need them in this particular scenario. So to use them, I'll run my command Terraform apply --var file is equals to eng.tf vars. So in this case, Terraform is going to go and pick up these variables here and then use the environment variables of the EC2 instance where I'm located to go and run the commands on the EC2 on the AWS console. So I don't actually see the key, the access socket key. Terraform sees it, but me, I give access to this extra variable that I need to go and run on the environment, on the ENG environment. Same thing for the prod and same thing for the QA environment. I don't know if I answered that question at the same time, Mr. Greg.
But to some degree, you elevated, you gave me a solution. I still need to go study this stuff some more.
So explain your question in another word. Let me see, maybe I'm missing something.
I think maybe as we go further, it will make more sense. He might be taking up a scenario.
Okay.
Is that fair, Greg? Or?
Yeah, there's a scenario where you do a module and then you have to refer to some credentials somewhere else.
Okay, now do you, for example, in this scenario, do you already have an idea of where the credentials are? Are they in a file? Are they already as an environment variable, or are they in the vault, or any idea?
Maybe they're in a file somewhere.
Okay, in a file somewhere. Let's take that scenario. So what I'll do is, let me actually clear my screen here. And I have this module.tf now. I have this module.tf right now here. And I need to create a new file. And I'll call this, let me call it, let's see, credentials.tf vars, for example. Now in this credential.tf vars, let's say I'm going to put the variables inside here, some variables inside here. So let me see, I'm going to first of all create my access underscore key is equals to, and then secret underscore key is equals to, okay. Oh, I deleted that user. I need to recreate the user again. So let me go back to my IAM role. I'll create a different user because I didn't download that user key. That's all right. So add the user. Let me just call it cred. Permissions. Just give him administer access. Okay, copy this one. And I'll put them in here as my access key. Then copy this one and put them in here as my secret key. Perfect. Now, the next thing I need to do is I need to get my provider block. So instead of typing that provider block, I'll just go and copy it from our GitHub repository. So let me go back up here, go to my provider.tf, just copy the provider block. Copy him here. And let me say, let me go to my module.tf, create a new file here. I'll call it just provider.tf. And I paste it in there. All right. So right now I have all the files I need. Let me just delete this access secret key here. Let me put this in US East 1, US East 1. Okay. So right now I have all the files I need. Let's say in here, I'm going to call the variables here. If I let me not call anything, let me just run the command now, Terraform init. Terraform init. It's going to initialize our environment for us. Perfect. Now, if I do Terraform plan, it's going to ask me for something. asking for the credentials to access my account or access the AWS account because I haven't told him anything. He say error configuring provider, no credentials. So I'll tell him here, Terraform plan dash var file is equals to credentials.tfvars. By doing that, I'm telling him to basically go there to pick up the files, but he's unable to pick them up. Let's say root module does not declare a variable name access key. Oh, let's see, how do I wanted to make it very easy. Oh, let's see here. Okay, let's do that. Let's actually create that. So let me come here. I'll say access key here. Access key is equals to var dot access key, and then secret key is equals to var dot secret key. He wants for me to create variables. I didn't want to do that, to go that way, but I have a choice.
Why do you have var dots?
Good, good. Sorry?
Guys, why do you have the var dots access key? I know you created stuff in the credentials, but I don't see var dot access in those files.
Exactly. So if you look at this error, he says value for undeclared variable. The root module does not declare a variable called access key, but the value was found in credential.tfvars. If you meant to use value, add a variable block for the configuration. So it's asking me to add a variable block for me to be able to use this guy over here. So let me just declare him here. So how do I create a variable? You write variable. This is helping me to create something. I'll call it access key. Access key. I can actually stop like this, that's all. And I'll create a second variable, and I'll call it secret key. That's all, secret key. So if you look at this code right now, I have my provider, variable, and I have the content of the variable over here. Let's go ahead again and run the command. I think you failed. It's going to try to pick it up from that file. Okay. So you can see that based on this, what did I do? I did Terraform plan. Terraform, I want you to use this file called credential.tfvars to plan based on the code you see in this folder. And based on the code you saw in that folder, you can only see this file here, this module.tf, which contains the name, single instance, and this particular instance. So you can see based on the plan, he wants to create just one thing, which is what? One EC2 instance. From what? From this module that we created. And remember, we just copy the module and paste it, and just put our values here, and here. That is it. And change the source to be local source. Is that making sense now, Greg?
Yeah, someone, could I see that provider.tf file again?
Yes, this one.
No, the one on top.
Okay.
Okay, yeah, I see where those things got put. That's so pretty much you have the stuff for variable, you declare them, and then when you do the Terraform plan, you directed it to go get those variables from the credential.
Yes.
.tfvars.
Yeah. So basically, Terraform, when he wants to look for any value, he looks for values in files that end with .tfvars. Terraform never looks for values in files ending with .tf. Never. He always looks for values inside of here. So you must name your file this one for him to go and look for values. if you put your values in a file called .tf, Terraform will refuse. It must be in a file called anything. You can call it anything as long as it ends with .tf as is happy. Are we okay?
Yes.
Okay, so I won't go ahead and apply here because we really understand it's going to go and apply for the instance I can do it after, but that's fine.
Yeah, so this is good.
Is this good? Okay,
yeah.
Mr. Kennedy has been muted all this time. I guess he's busy right now. Let's just proceed. So do we have some time for us to do the Jenkins file today, or?
It is up to you. What do you think?
Well, the thing is being recorded, so if you have time to still do that, you know, I'm willing to look at it, but I don't want to take too much of your time. We've already taken a lot of your time, but I would like to see it if you're willing.
think we can see the Jenkins file. It'll be good to learn with the Jenkins file approach and stuff.
Yeah.
Yes, I like to see it.
Okay, let's do a little bit of that before we go. It's true.
Okay.
I had to go for a meeting, but it's already gone almost halfway. I'll just leave the meeting. I won't let it. Okay, so let me just close this actually. Close this. Okay, that's it. Okay, this is my Jenkins server here. So of course, in this is my Jenkins server. Let me just go to manage Jenkins. Oh, I need to log in again. Don't worry about it. Manage plugins. Now I already have a bunch of plugins installed before going into all of this. Next time we can actually do Jenkins instead of Ansible in Jenkins, but for now I'll skip it. For now I've added, let me just show us the Cloud-based plugin. This is going to help us for Docker, for him to build and push to our Docker server. And I've also added SSH plugin, SSH, where is it down here? Okay, this one here. Going to allow us to be able to use the credentials to access our EC2 instance. Can we do that today? Okay, not today, but at least let's do the one to deploy to our Docker Hub account. At least let's do that one. Okay. And of course, the last one, last but not the least, I have my Maven Invoker, Maven Integrator. I'm going to use POM files to create some WAR files and then enclose them in a Docker file or Docker image, and then push the Docker image into my Docker Hub repository. So let me just open my Docker Hub repository here, Docker Hub. Let me see. Okay, no login, sign in. I thought it was signed. Put here password. Okay, I thought it was already there, but okay, it's not there. Is that it? It's not it. Okay. Okay, good. I mean, save it. Okay. So let me go back to my Jenkins here. Go back to dashboard. Okay, create a new item. Maven project. Let me call it Maven_001 app _app, doesn't matter. Okay, so it exists. 001, it's fine. Maven project. Okay. So now I'll go right down. You know what? If I'm not Maven project, no, error, not Maven project. No. Let me delete this. Let's make it a pipeline. Let's make it more funky. Let me delete this Maven project. Delete the new one, new item. Maven_001 pipeline. That's better. Okay. So I'll scroll down, and here is where we can type our Jenkins file. Now, Jenkins, I have two types of Jenkins file. We have the scripted and the declarative. Declarative is the more recent, and it always starts with the word pipeline, while scripted always starts with the word node. The declarative is a more recent one, so I'm going to go ahead with the declarative. So first of all, like I said, it starts with the word pipeline. So I'll write pipeline there. Or in fact, to save time, I'll just click on sample pipeline here. Let's say Marvin. Okay. Hey, come back down. Oh, what are you doing?
I have a question. What if, like, to take the pipeline from an existing project, like you work with a company, maybe they have like a pipeline script somewhere to collect it from.
Yes. In that case, what you can do is you can click on this same bar here, select this pipeline script from SCM, select Git if it's GitHub, and then put the repository link here, and then put the Jenkins. It's usually called Jenkins file, so it's fine down here. Just make sure the branch name is correct. And if there are any credentials, put the credentials, and then put the repository GitHub link over here. And Jenkins will pull it from the GitHub and then use it.
All right.
Is that okay?
Yeah.
More or less teaching us how to create, how to do the syntaxes of building your own pipeline script, but that's part of our job.
Yes. So let's see here. Let me take a simple hello world. Simple. I just clicked here and I selected hello world to just open it. So you can see it's a very simple pipeline. You can see it starts with pipeline, agent, any, stages, stage, steps, all of that. Let me just apply and then save and then run, build now.
Build now.
And you'll see you just echo hello world for us. Hello world, finish. Simple, beautiful. Now let's take it a step further. I'll come down here and I'll add some stages. So first of all, I have an agent, but I want to use a tool. The tool I want to use is going to be Maven. So let me open my server and go and look at if I already have Maven installed. I already do, but I'm just showing you when, because I'm recording this so you guys, when you watch it, it's going to make some sense. I go to my global tool configuration. And I can see down here, I have my Maven installation, and I called it m2_home. Okay, so I need to keep this name in mind. I come back here, and I said I want to use some tools. And of course, open your bracket, open and close it. And I need to tell him the name of the tool I want to use is called Maven. Now, what is the name I've given to Maven inside of Jenkins? I've given him the name
m2_home.
Exactly. Perfect. So I'm good there so far. So far, so good. Now, my first stage, I want to give it a name. Now, in this point here, it is just a name. It doesn't matter. It is just a name. But let me give it a name that makes sense. Let me call it Git check out. Let me put small letter here, Git check out. And what are the steps? I want you to, first of all, get something from my GitHub repository. To do that, I need to use the pipeline syntax. So click on pipeline syntax down here. It opens, select here. You want to look for Git, this Git down here. Repository URL. Let's see, where's my GitHub repository here? Let me open my GitHub repository URL here. GitHub.com. Let me use this repository hello node, doesn't matter. Copy it. And then I'll go and I'll paste it. No, sorry. Paste it in here. Okay. Now, if this was a private repository, I will need to add the credentials, but it is not a private repository. Yeah. So I'll just write my branch name as main. And come down here, click on generate pipeline script. That is it. Copy this. And I come back here and I paste it down. I wipe all of that and I paste it here. Let me just stop here for now. I'll stop here for now. Apply, save, build now. So right now, I'm just expecting for the Jenkins file to check out the branch for me. That's all. Just check out. Success. Perfect. Now, let's take it a step further. I'll ask this Jenkins file, I'll ask Jenkins to check out and then build my application. So I'll just copy this stage. Copy it because I'm going to create a second stage. Let me look for this open bracket. Where's the open bracket closing? It's closing down here. So I'll copy this, copy it, press enter, paste it there. Put on the same line stage. But I'll call this Marvin build. Marvin build. Remember, that's just a name. You can give it any name. It is just a name. But here now, it's not going to be this. Now I know Marvin is in the shell. It's a shell command. So I first of all put sh, and I open my quotes. Now, what are the commands we always use with Marvin? Is always clean install package. I'll use it here, but with the mvn command, which is the Marvin command. So mvn Marvin, I want you to clean install and package. Now I need to make sure that I have a POM file that Marvin is going to work on. If I go to my repository here, I can see that I do have a POM file right here that Marvin can work with. Okay, that is perfect. So I can go back here. So Marvin is going to work on this POM file, and is going to clean it, install it, and then package it. Okay, apply, save, build now. He's going to go ahead and then try to do that for us and then create our WAR file for us. Okay, success. So you can see it created our web app.war. That's fine. Let's take it a step, even a step further. Now let me go back to this project, configure. So now after doing that, Marvin, I want you, after building, let me copy this one again, copy this. I want Jenkins, after doing this, to basically enclose this in a Docker image. But for him to do that, I first of all need him to build a Docker image, and then he can log into my Docker account and then push. But first he needs to build. So here I'll put here, I'll call it Docker image build. Now what are the steps? We all know the command already. The command is Docker build. So I can remove all of this. I'll now do Docker build -t. Let's say I want him to push to my repository, and I know my Docker Hub repository name is apothecary. And let's say I'll tell him to push it to something called Marvin_001_ Tuesday or Monday, for example. Okay, that's fine. And at the end, of course, I need to put my dots. Docker build -t, all of that. So first of all, do the git checkout, build our WAR file, and then run this Docker build command. But now for him to run the Docker build, do I have a Docker file already? Let me check. And I do see that I do have a Docker file right here.
Yeah.
And in the Docker file, I've told him to copy the WAR file into the Docker image. It's a very simple Docker file from Tomcat label maintainer. It's me. Copy and then expose it. I don't actually need to do expose ATAT, but that's fine. Let me leave it there. So I can go back and continue. So it's going to check out, build, and then enclose in a Docker image. Apply, save.
Question: when you do that checkout, I don't know why you put that command checkout in
This one?
Yeah.
It's just a name. I can call it anything.
Yeah, so it pretty much just goes and it just, what does that it's like you have that step git branch. What does it do?
This command, this is what is basically going to copy the repository from GitHub into Jenkins. That's what this guy does.
Oh, copy it into Jenkins. Oh,
he clones it into, he checks it out into Jenkins or brings it into Jenkins so Jenkins can use it.
Oh, all right.
So sometimes they use the word git checkout or they use the word git clone.
Exactly.
All right, I got it.
So once he's going to bring into Jenkins, then Jenkins is going to notice that in this repository there's a POM file. He's going to create a WAR file from it using Maven, and then enclose that WAR file in an image called Maven001 Monday. And of course, the server where Jenkins is running already has Docker installed. That's why I can do all of this. So apply, save, and then build now. Where's build now? Here we go. Oh, now time is really good. I have about a few more minutes. Let's get it done. Okay, click on this. Console output. So you can see right now he's doing the from Tomcat, he's building our Docker image. Build a Docker image. Build a Docker image. So first of all, is from Tomcat. After from Tomcat is going to add the label maintainer, copy the WAR file we created, and then expose port 8080. Okay, you can see he added a maintainer, added, copy that file, expose port 8080, and then create an image and call it that name. Perfect. So let's go to the next step. Now we're going to ask him to not only build that image, we're going to ask him to push it to Docker Hub. But for him to push Docker Hub, he needs to log into my Docker Hub account. So let me copy this stage again. Let me copy this. So I cover all of this block. Copy, press enter, paste, and then make sure you bring this back indentation. Okay, yeah, I'm going to call it Docker push. Docker push. Okay, now for Docker push, like I said, we know we need some credentials. So I'm going to go down here, click on pipeline syntax. Or I can just click this use syntax. Let me just click on it again. Click on it. Open this window. You want to look for something down here. Let me go down here called with credentials. With credentials. Click on it. You want to use username and password separated. That one. So right now, I already have my credentials added. But for the sake of you guys, I'll just do it again. So let me click on. So imagine there's no credentials here. Imagine there's nothing there. Click on add Jenkins. And here I need to add my Docker Hub username and password. My username is Apothecary. My password is this. ID and Docker Hub and already in use Docker Hub 1. Okay. Docker Hub 1. Okay. So I put my Docker Hub username, Docker password, and ID and description. These two don't matter. Just put anything in the ID and the password. These two don't matter very much. So click on add. I finished. Now you can select what you just created among the ones. So this is the one I just created right here. Username variable. Now you need to give a variable that you're going to use to call your username. Let me call it user. And for password, PWD. Okay, I finished here. Click on generate pipeline script. Okay, copy this. And then come inside here. Let me delete all of this line here. And then paste it here. Good. I like indenting very well. So let me push it in front and let me remove this one. So I've pasted it there and I'm ready to go. But now I need to use the command to tell him to log in into my Docker account. And like we know, it is Docker login -u. What is -u? The username is going to be, I'm going to call this variable here. So $, curly bracket, user, and then -p. I need to call the password. So I call it again, $, curly bracket, pwd. I close it. So Docker login -u, user, and -p password. And of course, remember, this is still a shell command. So I need to put sh in front, sh, and then put it in the middle of quotes. It is still a shell command. Let's not forget. Let me remove this space here. Okay. So it's going to do Docker login, log into my AWS account, into my Docker account, and then after that, I want him to do Docker push, and I need to put my image name. Let me copy my image name, copy it, and then paste it here. So what's going to happen here? Let me expand this a little bit. After doing the git checkout, he's going to build my WAR file, enclose it in a Docker image, and then push the Docker image to my Docker Hub account, my Docker repository, basically. So that is it. Click on apply.
I don't think the password will work.
Why not?
I think the passwords that you added was made up of was it still the same one? But never, don't mind me. Don't mind me.
Is it making sense though?
He used
Yeah,
the real
it's
password. He
it's
used the
just-
real password.
Oh, you used the old. Oh, then it's fine. Then don't mind.
Remember, this is a variable, and I enclose my password inside of this variable. So my password is not actually PWT. It is something else, but the variable is called PWT.
Yes.
He
Okay.
built it from a pipeline script.
Exactly. I remember I went to the pipeline syntax in here to do it. And I generated this script. Okay, so now I finished, apply, save. Unless I made an error on my password, it should build, compile, and then push. Let's go check it out. Console outputs is building. So now he has logged into my account. You can see login succeeded here. And now it's pushing to my Docker repository. Success. So now I should go and see an image called Marvin001 Monday in my Docker account. Let me refresh. Marvin001 Monday. Here it is. And that is it. So basically, that's a very simple way or example of using the Jenkins file to basically build, compile, and push. What am I doing?
What if I need to ask? It's like I see Tomcats at some point in there. What if I need to access like what was done inside the Tomcat server? Like I know the stuff got likely deployed. The Hello World likely may have been deployed into Tomcat server. Like how do I go and see it there?
In the Tomcat server. Now,
Yes.
if you do have the Tomcat credentials, you can log into a Tomcat server and then view it inside of the Tomcat server.
Oh, all right. Okay.
Yeah. That makes sense?
Yes.
Okay. Any other questions about
This
the
is pretty
Jenkins file?
good.
Okay.
This is pretty good. I don't know. You thanks a lot for the time you spent. I know you're a pretty busy guy.
You're welcome. So you're very welcome. My honor. It's my pleasure.
Thank you very much.
You're welcome, sir. So I will be the recording should be compiled within the hour or two, and I'll be sending it to Walter, or maybe I don't know. I can create a group or something, send to you guys. I don't know, how do I do it?
You want me to send that link you forwarded to me to them as well if they want to join in, or the link you sent to me? But you can, if you forward it to me, I can forward it to them.
Yeah.
I can create another group and add you in it if you don't mind. But it's up to you.
So that's fine. Yeah, I don't mind.
Yeah, I can add a group and put everybody in this meeting, and you can shoot it in there.
Okay, sir. That works.
This is very helpful. Might bug you later in the future again when you get time. I know you're busy on Ansible.
Ansible, yeah, I know.
Yeah, Kubernetes.
Yeah, I haven't forgotten the Ansible part, even the Kubernetes part, but yeah, we'll work on it. Just make some time and do that again. Yeah.
Thank you very much. I know it's late.
You're welcome. You guys have a great day.
You too. Thank you.
Thank you again, and you take care.
You too, sir. Take care. Have a nice one. Bye-bye.
Great lecture. Bye.
Thanks.